me with this. Darn it. I never finished the other sheet, did I?
No.
Did we answer the first question?
We just did the first one.
So we did answer the same
Yeah.
question. Yep. All right, second question, so that you can read it. So I got another reservoir. Hold it, I need more space. I need to erase on this. So I hope my blue's okay. I ran to the Math Center, there's no black pens left.
Is this 1.6 or 1.7?
I don't know.
I don't think it's 1.6.
Is this 1.7?
It's 1.7. So you guys, take a peek at my second example. I got yet again another reservoir. I do not want to keep rereading my question in English, so if you don't mind, I'm going to draw a funky little picture, and as I'm reading it, I'll put the information in my picture. It has a capacity of 100 million gallons. It's initially, however, only half full of water, and it supplies a nearby city with only 500,000 gallons of water per day. 500,000 gallons per day. Suppose also that there's a part that this is partially refilled by a spring that provides. You guys help me, is it 9/10 million gallons per day?
Yeah.
But also, I lost it, gallons a day, but also an additional 1/10 of a million gallons per day.
Now this picture you're writing, makes it look like the most inefficient reservoir system with its milligrams.
Oh, you're right. My apologies. You're absolutely right. I didn't even catch that. It was a small picture. And by the way, the spring is completely clean, and the runoff is of the water, still water, has a concentration of 0.0001 pounds per gallon. So this particular flow coming in has, I lost it again, darn it. 100,000, is that 10,000? Can you help me with
3
this?
zeros.
Is it pounds? Per gallon, thank you. Now, let's assume there's initially 200 pounds of salt in the reservoir, and that the all-familiar mathematical God keeps the reservoir well mixed with the metaphoric spoon, and let's find the concentration of salt in this reservoir as a function of time. Guys, can you not? Like my last example, I think it's too difficult. Can we instead just find a function for the amount of salt in the tank at time t? And when I'm done with that, I'll divide by the volume of fluid in the tank, and that'll give me the corresponding concentration.
So, if there is altogether 1 million gallons going into the tank per day and only 1/2 coming out of the tank each day, isn't it just going to be overflowing all over the place?
Eventually. Yes, and I could have asked that. And I haven't asked, at the time where it overflows, then can you give me the concentration? That would be a very viable question. This question's a bit more limited. I'm just saying as time goes by, give me the amount of salt in this tank. It's just that the mathematical model is only going to hold until the tank actually fills up.
Okay.
So I'm kind of implying that in this example, although I could have stated it more clearly.
Okay.
So you guys, give it a shot. I think my initial setup is just going to be like my initial setup of example number 1. I still think I'm going to talk about how the rate at which the amount of salt in the tank is changing over time could be interpreted as a difference between the rate at which the amount of salt is coming into the tank and the rate at which the amount of salt is going out. It's just that when it comes to the rate at which the amount of salt is coming in, I'm going to make a mistake. This is not it. Because I think what I have on the right-hand side of the equal sign, if you're careful with my choice of words, is the rate at which the fluid is coming into the tank, not the rate at which the amount of salt is coming into the tank. So what I'm going to do is multiply the rate at which the fluid is coming in the tank by the concentration of salt within that body of water coming in. And I think that's going to give me, collectively speaking, above this brace, the rate at which the salt's coming into the tank. I'll multiply by my 1/10,000. measured in pounds per gallon. And you guys, I typically in equations suppress units. It's just it was my initial setup. I include them just to make sure I'm not making any silly mistakes. Minus, you guys come to a salt for a minute. Sorry, right? Minus the rate at which the salt's going out of the tank, but yes or no answer. Is that this? No, wow. Oh, that's the fluid flow. That's the rate at which the fluid is flowing out of the tank. I need to multiply that by the concentration of the salt in this particular body of water going out of the tank. Oh shoot, I can't. I didn't give you the concentration of salt in the tank, or did I? I turned off the computer. Did I forget to write that down?
200 pounds.
Where'd you get the 1/10 gallons per 10 days?
I said the amount, the water coming in from surrounding land, the runoff, was 0.1. Correct.
This is just salt water coming in, right?
Insert, sorry, Chris. Chris, if I wanted all the fluid coming in to the reservoir, I would have added 9/10.
That's what I asked.
But I'd have to multiply by the concentration of salt, which is 0. And so the whole term is 0. That's why I did not include it. But you can include it. In the end, nothing will change.
Why don't we take into account the 9/10 that are flowing in?
I can. I can add to what's above my brace with the 9/10, because that's the rate of flow of fluid from, was it spring?
Spring.
But I gotta multiply that by the concentration of salt. But it was clean.
But since the water level isn't constant in this problem, doesn't that dilute it?
What a good question. Emphatically, yes. And so I think in another portion of this D that I'm creating, you will see that it comes into play rather heavily. I just think it doesn't come into play with the first term, because here I'm talking about the rate at which the salt is coming into the tank. And so I think for the first term, it has no bearing. I think in the second term, it'll be a big deal.
The second term is going to be the actual fluid.
I think the second term is going to literally represent the rate at which the salt is leaving the tank. And so you guys help me with this. I forgot, what did I say with the concentration was?
200 pounds
It
per day.
was
It's unknown.
not given, that's the question. The question is, what is the concentration
Yeah.
of salt in the tank as time goes by? And since I don't know what it is, interpret it this way. I'll think of the concentration as the, how about the amount of salt in the tank divided by how much fluid is in the tank? But the amount of salt in the tank is unknown. Call it A. However, when it comes to the amount of fluid in the tank, I need some help with this seriously. I said initially it was half full.
Yeah.
So I think initially I've got 50 million gallons. It's just that. Check out how it's going to have an effect with that 9/10. I think collectively speaking, forget about salt. Collectively speaking, let's talk about how much fluid is coming in. It's coming in at a rate of 1 million gallons per day. Leaving out only 500,000 gallons per day. So per day, how many gallons am I adding? 500,000. So I will add, I will have to add my 1/2 million per day that passes. I'll treat T as time, measured in days. You guys, is that okay? All right, if it is, number one, I've accommodated the fact that the 9/10 has an effect on the concentration of salt in the tank at time T. Number two, look at how beautiful that is. It's an equation. That's a differential equation. For my dependent variable A in terms of my understood independent variable T for time. Let's clean it up. Actually, I misspoke. Let's not clean it up. I think I've got mistakes in here. Because I think I forgot my units for A, which the amount is measured in pounds. I think I can clean up my second term in terms of units because, I'm sorry, Alex, I did the MG again. That's million gallons. But I think I can cancel. Oh, check that out. That makes sense. Now my units are going to be pounds per day. That should be the units for the rate of change of the salt in the tank. And I get more cancellation. I'm left with 1 over, is that 100,000? Is that 1 over 100,000?
Yes.
No, I don't think it is. I think I've got some other mistakes in here because I need to make sure these units can cancel and they don't. Shoot. Because 1 million gallons looks like this. Now my units are going to cancel, and let me be careful with my arithmetic. And in being careful with my arithmetic, does that end up giving me, in the end, I really have no clue. Is that just a 10? So D80T is equal to 10. You guys mind if at this point I suppress units?
Yeah.
Minus my 1 over jeepers, is that 100 plus T times A? Or shall I say, jumping to the right board, I've got a D80T being equal to nothing more than a 10. Oh, excuse me, I misspoke. Can I say plus? You guys are too far away. Is it this?
Yeah.
Is it this?
Yes.
Just so I don't have to look. Ah, shoot, look at that. It's a linear. First order DE.
Wait, I think I found a problem.
Uh-oh.
Where you simplified the 1 million minus 10,000, that's 100, not 10.
Well, it's divided by 10 by itself.
Oh, you're right,
divided by
Brad.
10 as well.
I just
Oh, but you
figured
multiplied
the
the
factor.
10 by it. Okay.
Yeah, please double check my arithmetic.
Okay.
Next, let's find a integrating factor. And I think with the integrating factor as a function in T is going to be e to the power. Oh, I've got the darn problem again. I keep hearing my own voice.
1 over 100 plus 2.
Do you guys agree?
Yeah.
And I maintain that when I multiply, that's hard to erase. When I multiply both sides by the integrating factor on the left-hand side, you guys, as usual, you see me do this several times already. I've got the derivative with respect to T of the product of my integrating factor with my dependent variable. But like I said, I'm multiplying both sides by that integrating factor. So when I undo the differentiation process, I don't know, you guys, can you integrate this for me? Five times 100? Did I walk in the right classroom?
Plus T squared 2.
Plus T quantity squared thing. Plus C makes a difference. And in isolating A completely, you guys check this out. I do indeed have to have that A as a function of time T. And I think it's nothing more than 5 times the quantity 100 plus T. Plus C over the quantity 100 plus T. Oh shoot. We're not done. There's some information we need to add into this.
Why did your square go on the outside?
Because you divided 100 plus T.
Well, I upped this exponent 1 by 2. Divided by the new exponent 2. But 10 has to justify it. You just watch my arithmetic, tell me if I made a mistake. But you guys, I think there's some information given. I told you that the amount of salt in the tank T initially was, I'm being honest, I don't remember. So it's 200 pounds. So A of 0 is equal to 200. But you guys, this is going to allow me to find the value for
C.
for C. And that being the case, plugging 0 for T, simultaneously plugging 200 for A, I think it gives me this. 200 is equal to, I really don't know. Is it a 500?
Yes.
Is that a plus C over 100? But that tells me C is going to be equal to, you guys always make me do all the work. Negative 30,000. And you guys, if I'm not jumping around too much, can I scoot back into the middle ink board? I suppose what that really means is that my function for A as a particular solution with the initial value condition is nothing more than this. 500, or excuse me, 5 times this. Plus my C over 100 plus T. I want a yes or no answer. Does that answer my question? No, I think I failed to do it. Actually, the question was,
Concentration.
yeah, find concentration of the salt in the tank at time T.
So I need to put it
So I do think I need to say this. C, a T as a function of time, so you don't confuse it with that constant, can be interpreted as a ratio, the amount of salt in my tank at time T. to the volume of fluid in my tank at time t. And so I think that merely gives me, shoot, what was the volume? As a function, the volume was
Plus 1/2 T plus 1 T.
50 plus 1/2 t. And so dividing this first term by 50 plus 1/2 t. Is that a 10? And do I need to consider subtraction, not addition? I mean it. You guys wouldn't make me do all the work. Is that a 60,000? Over 100 plus t? Twice? Silence is creeping in. Is that okay?
Looks like it. So,
Yes.
this might sound silly, but how did you find the volume?
Wasn't
So it's
already
kind-
given up here. We already found.
Well, I see that, but how did you find that equation?
So how did I come up with this initially?
Yeah.
I was this lazy. I said, initially you were told that the tank was not completely filled.
Okay.
I said English is a tank with this capacity. However, since the tank was only half full initially, I knew there was only 50 million gallons
Okay.
in a tank at time t. So that's where I got the first term. But I got to add to that how much, sorry I'm so slow, how much water's coming in or being added to that as the days pass by. Let's talk about one day.
Okay.
I think of one day. Here's how much is leaving as water. The amount of water coming in, however, is the sum of these two values, which is 1 million. And so I think taking in 1 million gallons coming in, but subtract from that 500,000 gallons going out, means that every single day I'm adding an extra 1/2 million gallons.
Okay.
And if T represents time measured in days, I will add to the initial number of millions of gallons, 500,000 gallons per day.
That makes sense. All right.
It's just an expression. I'm not gonna- so-
Can we go back to the part before you integrated up on the side?
Yes, before I integrated, it's right up here.
When you had the 10 times 100 plus C, I distributed the 10 and when I integrated that.
You know what, that's fine. This is Chris, in the end, I think it kind of looks like a mess over here, and when you divide both sides bit by this, you might not see that it cleans up so nicely unless you took the time. And you took that nasty big trinomial, and you factored it, and get what I get, and you simplify. I just think it's a lot of work. Chris, I cheated. I did not come to class today having written this example and did it in my head, or did it on paper. I was just noticing that since these two things were identical to each other, I just thought if I raise this to the second power, then in the end I'll be able to divide that out. So when I'm writing this in the board as I'm going through the problem, because it's new to me like it's new to you, even though I wrote it, I just clearly see that it's either, since these are the same, even though I'm going to integrate on the right-hand side, I know I get to clean it quite nicely if I leave this in the form of 100 plus t to some power. Again, just being lazy.
Looking at the concentration equation, would it mean that the concentration is going down with time up until the point that the tank is full?
See, I disagree. Don't look at the 10, don't look at subtraction. I think initially, this is a decent number. But if, as t gets really big, it goes to 0. So as time goes by, this fraction is going to 0, and therefore I think I'm subtracting for 10 something that's going to 0. I think that's a concentration that increases up to 10 as time
Yeah.
goes by. Anybody else want to attack me on this, please?
Could do another one.
Isn't there a third application?
Do you guys think I can at least erase the middle board?
What were the initial conditions? What were the initial conditions?
I'll show you they're coming on the screen right now. Sir, since it's so slow. One of the initial conditions was that initially this tank with this kind of capacity was only half full.
Yeah.
And so if I were to write that in terms of mathematical symbols with my red pen, I would have said, well, initially the volume of the fluid of water is equal to only 50 million gallons. And because my computer's so slow, I think the more important initial condition that allows you to find the constant C is that I told you the amount of salt in the tank initially was it 200 pounds? And sorry, I turned off the computer, I just wanted to rest my space. So everybody, sorry, I misspoke. I did not mean the word everybody. I meant the word somebody. Can somebody tell me where this comes from? Given a circuit, in this particular circuit, I've got a resistor measured in ohms. I've got an inductor measured in henries. I could have had a capacitor measured in farads. I've got a voltage source. I like the letter E to stand for. I like the letter E for voltage because it stands for.
Electrocentrals.
Oh, how about electromotive force?
I haven't taken electromagnetism.
And you guys, I'm being a little goofy. I do not assume you know
That
circuits.
thing.
What's that?
I keep forgetting that thing.
But if you did know that, then you probably also know the law called
Ohm's law.
Kirchhoff's voltage?
Kirchhoff.
Or is it Kirchhoff's voltage?
Kirchhoff's formula. The Kirchhoff's law simply says the sum of the voltage drops equals the total voltage applied to a circuit. Now, you guys, can I not go into details of the physics today? Because this is too goofy. I'm only going to generate a first order DE. I'd rather go through the details of the physics and where the equation comes from when I come to solving higher order DEs. So can I leave the details later? Now, just trust me, if this formula holds, I know it sounds awful. But like I said, it's just too easy. I'd rather talk about the details when it gets more complex, with multiple components of my circuit. I'll do that in several weeks. For now, check out that if this law is really true, and if L and R are constants, then I think I got a differential equation of first order that's linear. As a matter of fact, if you guys don't mind me scrolling down a tad bit, for this particular circuit, what would happen if I told you did I tell you anything?
No.
Holy cow. Oh, I did, okay. Suppose that I know my inductance, I know my resistance, and my electromotive force is actually non-constant. Then I think I can plug this into my differential equation and solve. All right, I've only got 6 minutes left. I guess I'll do it. L is 1, R is 2, E is 10 e to the negative t. I'll stick it into that differential equation. Did you guys see how this would be a silly test question? Because I can give you that equation since I assume you guys are not physicists or engineers. I can't assume that. And therefore, all I'm going to do is plug this information in that DE. And if I substitute 1 in for L, 2 in for R, that exponential expression in for E, I think that gives me that the rate at which the current is changing with respect to time. Plus 2 times I is nothing more than my 10 times e to the negative 2t. Ah, you guys, piece of cake. That just simply means that my integrating factor, do you mind if I don't use the letter I? Integrating factor. My integrating factor, I've got the right words, is merely going to be e to the 2t. It's just that since I proved this in class, I think in multiplying both sides by that beast over there, the left-hand side transforms into something that really should be the derivative respect of time t of the product of the integrating factor and my independent variable, my dependent variable r. And on the right-hand side, oh shoot, this is too nice. So that one integrate. In other words, undo the differentiation process with respect to t. Do you guys agree? Or shall I say, I at t is equal to 10t times e to the negative 2t plus c times that thing. Oh, by the way, I think I added something to this. I don't know if you guys can see it. Let's find I as a function of t if it's also known that I of 0 is equal to 0. But if I of 0 is equal to 0, then when I plug 0 in for big I, and simultaneously 0 in for t, doesn't that give me this? So rewriting, I guess it means the current as a function of time t is nothing more than this. guys, what do you think happens to the current over time? How do you do it goes to zero? I mean, when I plug a really big number in for t, this is close to infinity. This is close to zero. What's that?
Yes, L'Hopital's rule.
L'Hopital's rule only applies to 0 with 0, infinity with infinity. I said, L'Hopital's rule only applies with a 0 with 0 situation, infinity with infinity. I said,
That's the case.
that's the case.
We have
After all,
2t
you
over-
throw this negative exponent thing downstairs, you get
Uh-huh.
divided by e to the 2t. I really do get an infinity divided by infinity. So what do you do next?
You differentiate.
Top and bottom differentiate applying
L'Hopital.
L'Hopital's rule. A lot of you don't know me, but you know I've got one of those nice big calculators. And this calculator I'll have out in every exam. And if in your mind you're pronouncing the word in French incorrectly, it'll catch you if you're doing that. I'll do that points. L'Hopital's rule.
Not Loopy Hospital?
Stop it. You guys said, okay, I feel like I rushed it, but I think I can rush it. Because if I'm not expecting to know this off the top of your head, and I give it to you with all the other information, doesn't that really mean you're just slapping this garbage in? It's not nearly as sophisticated as my last two examples, I think. Because you're not creating the DE out of them.
So,
Yes.
before class is over today, would you be able to maybe go over what's going to be on the test next week?
Yes.
Okay. That way we can get ahead this weekend.
So
if we-
Monday and Tuesday.
What day's the test?
Thursday.
All right, here's what I want to do. I've got 1, 2, 3 or 4. Shoot, I think they're all my examples. The exam will not go through go past 1.9.
Will not go through 1.9?
It will not go past 1.9.
Okay. Is there anything that maybe just won't be on the exam, or is it going to cover everything that we've done so far?
Yeah, how about this? I write your exam this weekend.
Yeah.
I will not write an exam any vocabulary questions. So just concentrate on solving DEs, maybe the other things like checking solutions, maybe looking at orthogonal trajectories, maybe looking at isoclines to build slope fields.
Okay. The applications from chapter 1, though, I mean, that's the only thing I've been a little unclear on so far.
Okay, listen to me carefully, including both applications you see in the book, and application you will see me write and add as additional homework on Monday.
Okay.
Yes. Can I wait as far as Friday?
Yeah.
As a general question, in this class, will the difficulty of any problem be located in like the differential equations part of the problem, not just the integrating of it? The bulk of the difficulty,
Not yet.
but eventually.
I think so. Just not nearly yet.
Can you repeat what you said about the application?
Yes, I think there's applications in section 1.5, 1.7. Oh, and in section, it's not in here. So I'm going to give you some more applications on Monday. But to back it up, I'll assign exercises. I'll just write them on my own and post
So-
them as a homework set on Monday after I cover that material.
Okay.
Okay. So you guys, I owe you 2 quizzes. I'll post them.
Can you please have them on there before 10 a.m. tomorrow?
Before 10 a.m. tomorrow?
Yeah.
Oh, that's a piece of cake.
Alright.
Okay, definitely. That means I can take as long as tomorrow morning. I'll do that. Can I give you guys some homework?
Yeah.
So the exam is 1.1 through 1.9,
Everything.
every section?
Yes, I didn't skip it.
Okay.
You guys ready?
Yeah.
Section 1.7. One through 7 on. Nine through 15 on.
So
Wasn't that just
1 through 15 odd.
Sorry, I'm making everything going along. Okay, you're more efficient than I am. Oh, enjoy your weekend, that'll be enough.
Okay.
Wait, 9 through 15 is enough.
1 through 15.
1 through 15.
1 through 15.
I said 1 through 7 on, then 9 through 15.
Got it.
I had a question about the quick.
Yes, sir. Yes. No, I didn't take it.
I was wondering why